Astrophotography is an art form, and each of us have our own different way of manipulating astrophotography data into our own artwork. But how do you do that? What are the basics to using these deep sky processing programs? Well, we're going to look at two different programs. One of them is free and it's called Siril, and the other one is paid for and it's called Pixinsight. And we're going to go through two very basic workflows on how to use these programs. Let's get right to it. We're going to get started with the program called Siril. And for this program, I have some data that I captured using the ZWO-585MC Pro camera on my ASCAR 70ED refractor telescope. And for this image, I got 2 nights worth of data on Caldwell 30, also known as NGC 7331, which is right next to Stephan's Quintet, which is a group of galaxies that are slowly consuming each other. So let's open this up in Siril and get started on the workflow. As soon as you open Siril, the first thing that you're going to want to do is switch this to auto stretch mode so you can actually view your data. And as you can see, we have a really strong gradient right here. So we're just going to crop this section out and make sure that our image is fairly well centered so that we don't have any issues when actually extracting the background here. Our next step is, again, one of the more important parts. You go to image processing, background extraction, and you can either place your own samples just by clicking on the left side of your mouse, or you can simply press generate. And this is going to automatically place your samples. Now, it is very important, if you look at this part, that you don't have any samples landing on a galaxy or a star. And the reason for this is because if you have one of these samples on a galaxy or star, then the computer program might recognize that galaxy or stars as part of the background, and it would mess up the stretching later on in the processing. For example, right here you have a star, as you can see, right in the middle of the sample. If you want to get rid of that, just go ahead and right click on your mouse or your laptop and it will get rid of the sample. Now, once you're happy with how many samples that you have, go ahead and hit compute background. And by the way, if you don't have enough samples, you feel like maybe you need more, just go ahead and bump up samples per line, as you can see, like that. Or if you have too many, go ahead and lower it down just like that. Now, maybe you have some samples landing on your galaxy, go ahead and up the grid tolerance and it should be able to get rid of some of that. You kind of just have to play around with these settings to see which one works best for your data. Obviously, all data is going to work differently because it's from all different locations in the world and all equipment is different. So just play around with it, see which one works best, and then you can go ahead and do that stretch. Now, once you're happy with that, just go ahead and hit apply after you've already computed the background and you're ready for the next step. This next step sometimes works and sometimes it doesn't, and there's always a workaround. It's the color calibration. This next step is extremely important because it's going to allow you to get accurate colors in your image, and if you don't do it, then the coloration is going to look very yellow, maybe green. It's not going to come out right. So you go ahead and, again, image processing, color calibration, and photometric color calibration. Now, you have to look up which name in the catalog your deep sky object is. For example, as I said before, I'm doing Caldwell 30, which is also known as NGC 7331, and you want to find that. You have to make sure that the focal length and the pixel size is correct, otherwise it will not be able to plate solve correctly. For example, my telescope has a focal length of 490, so this is correct. Since I did crop a little bit, it's setting it as 490.7. And you want to also look at the pixel size of your camera and set it as that. As for example, the ZWO-585MC Pro uses a pixel size of 2.90, leaving me with a resolution, as you can see, of 1.219. Again, if you don't have these set correctly, it's not going to work right. So after you type in image parameters, you click on the deep sky object that you want to use. Make sure that these coordinates do change, or sometimes the its header will have the parameters all saved. You don't really have to do anything except for hit OK. But sometimes this works, again, sometimes it doesn't, and I'm going to show you guys the workaround for if it doesn't. So after you have all the settings correct, you go ahead and hit OK. And as you can see, it worked correctly. If you look here at the console, you'll see that the photometric color calibration succeeded, and you can see a slight difference. It actually flipped the image, allowing it to see what it would actually look like if you were to look at it in the night sky right now. Now, perhaps this doesn't work and you have to do it manually. Well, here's how you do it. You go to image processing again, color calibration, click on color calibration again. You want to first select your background reference, just like this. Use the current selection. You want to neutralize the background. Zoom back out and zoom in on your galaxy and go ahead and select this part of the core. Definitely don't do this if it's nebulosity, because you end up with SHO palette, which is kind of hard to correct in Siril, in my opinion. So if you're trying to do it on nebulosity, don't do what I'm about to do. Only do the background neutralization and then hit apply. If you're doing a galaxy, go ahead and select the core as well. Use current selection and hit apply. After that's done, you can go back, and if you want to have the same kind of field of view, perhaps just flipped, go ahead and go to image processing, geometry, and you can do a horizontal mirror. And as you can see, it's now the same as it was in the photometric color calibration. Also, if your image seems to get off centered and you want it back in the center, just go ahead and click on this button here and it will recenter your image just like that. All right, so that's done. Next step is remove green noise, because as you can see, it does have a little bit of a green tint to it. So you go to image processing, remove green noise, hit apply, and that should be good. And the next step, you have to make sure that you have StarNet 2.0 installed on your computer, installed within Siril. Again, I have another video on how to do that if you want to go to my channel and look at that for yourself. But this is a very important part if you want to stretch your galaxies or your nebula without actually stretching the stars and oversaturating them as well. So you go ahead and switch this back to linear mode. Go to image processing, star processing, StarNet star removal, and you do the pre-stretch linear image. Now, that's all you have to do here. If you don't pre-stretch the linear image, then it's not going to work right. So make sure you have that checkbox done properly. Generate star mask, you want that because you want to be able to bring the stars back in later, and you hit execute. Once StarNet star removal is done running, you go ahead and switch this back to auto stretch to make sure it worked correctly, and as you can see, it did. Now again, we still have some vertical banding here, and we're going to get rid of that real quick. Go to image processing, banding reduction, and switch this to vertical banding and hit apply, and this should work right. As you can see, it added some more bands here in order to pretty much even everything out, and it worked nicely. So we're going to save that. I do want to mention as well, as you go through each step and are happy with each step, make sure that you save it just in case maybe your computer crashes. You don't want to lose all the steps that you've already made. All right, next you go to linear mode again, because now it is time to stretch. Go to image processing, and there's two different ways that you can stretch generally, and there's two different ways that you can stretch with nebula. It's recommended that you use a generalized hyperbolic stretch, and I'm going to show you how to do that. So with nebula, what you would want to do is zoom in on auto stretch just to see what part of the image is actually the data that you would want to stretch. You select that area, very small selection, it doesn't have to be big, and you set that as your symmetry point. Then you go ahead and switch this back to linear mode again. Make sure you have the field of view correct, and you can begin stretching this data. And as you can see, the image is stretched, but the background is fairly bright. So how do we get rid of that? First, we hit apply here, and this might take a few times. You don't want to select the core as the symmetry point because it's just going to over brighten the core and it's not going to stretch everything else. So it's more valuable if you were to stretch the dimmer part of the galaxy or dimmer part of the nebula first instead of focusing on the core. Once you're happy with how it's stretched, you hit apply, and then let's get rid of this background. You go to image processing, histogram transformation, and you can go ahead and bump this up to 50 to get a higher zoom, and you can begin to bring this black point in. Perhaps if it's zoomed too far, and you can go ahead and press this little 1 button and it will bring you back to the zoom it was before. You can go ahead and bring this back up. Of course, you want to make sure that you're not clipping any data, so it would be wise to have a little bit of a zoom. As you can see, the data is here. This is where it ends. So you don't want to stretch beyond that point, because if you do that, then you'd be clipping the data, and that will make your astrophotography image look really ugly. So you hit apply here, and you just keep doing that until it reaches the point of darkness that you like. Personally, I'm happy with that level of darkness, so I'm going to hit apply here. And to adjust the core brightness, you kind of just mess around with this, but as you can see, it's just too bright for me to do much with. So I'm just gonna close this now. As you can see, I'm happy with that. You can see Stefan's Content right here. It has 1, 2, 3, 4, 5 galaxies, and we have NGC 7331 right here as well, with other galaxies right here in the picture. And the next step, we're almost done here in Siril. It's the color saturation. So we go to image processing, color saturation, and you don't want to mess up the background too much. So you up this background factor just to make sure that the background doesn't get saturated, and you bump this amount up. Obviously you don't want to do it too much because you don't want the pixels to look oversaturated like that in purple and magenta. So you kind of lower this down until it's a tolerable amount of color and that it still looks correct. So once you're happy with it, again, you hit apply. It's one of those things that you really have to play around with, see what you like. Again, it's an art style, play around with it, see what works for you. And once you're done with that, you save it. It's very important that you save it before this next step. You go to image processing, star processing, and we're gonna bring the stars back in now. So let's click on star recomposition, click on the background stretch here, and you're gonna find the starless version of the image that you already stacked. So here we have, for me, starless C30, and we're gonna hit open here, and there's the image that we just now stretched, and then we're gonna bring these stars in. That's gonna be called star mask C30 for me. It's always going to say either starless or star mask. That's how you know which one's which. And you hit open, and there these stars are right there. So these are the basic steps. As you can see, we just close here and we save this as a unique file. We save it as a PNG for you to be able to put on your phone and share with your friends and family, whoever it is that you want to show. And as you can see, my image is right here. So there's a fairly good amount of detail. Obviously, I do need more exposure time to help get a darker background, giving the galaxy more contrast. But this is the basic steps to use in Siril for post-processing. Now let's take a look at Pixinsight. For Pixinsight, you go ahead and move it over here. All right, so I have my data now opened here on Pixinsight, and I'm gonna bring my workflow in here. Just to save. But I'm gonna show you each thing step by step using the Process Explorer. So the first thing that you want to do is go here to this Process Explorer and type in screen, and you're going to click on screen transfer function. Now you're going to be using this every now and then. It's pretty important. Go ahead and search that and open it up. And first thing you want to do is unlink it and hit this little radioactive button, which means auto stretch. Here is our auto stretch data. We're going to move it to the side, and again, just like we did in Siril, we're going to give it a little crop to make sure we have the field of view right. For the Process Explorer, we're going to type in crop, and there we go. We're going to open up a dynamic crop. It's not like Siril, you can't just drag and drop the area that you like. You have to kind of just drag it around until you have the field of view that you find desirable. So here's an example. You just go ahead and move these little edges and then center it how you like it, and once you're done, you press this little check button. All right, so now we can zoom into our image, and there it is. Now we're going to pretty much follow the same kind of workflow as we did in Siril, but on this program. Obviously, this program has a lot more tools and a lot more plugins that you can use, which is why it's such a good tool, and that's why you kind of have to pay for it, because it has a lot more customizability than Siril does. So again, we have the auto stretch done. Now our next step that we're going to want to do is our background neutralization. So you go ahead and open that up. Again, if you don't have it already up here in the recently used, just go ahead and type it in. You want to select a background as a reference image. Again, using the previews, select that area, and then open that preview in this menu here. See preview 1, hit OK, and we're going to go ahead and press a little square here. As you can see, it kind of turned it yellow. So all you have to do to fix that is auto stretch it again. And then we're going to do our dynamic color calibration. We go to Process Console, and we're going to type in color calibration. There we go. We have it right here. We're first going to select our background. So choose an area that has no galaxy or no stars in the way, and we're going to select this as our background reference. See, for me, it's preview 2. And hit OK here. And then for the actual galaxy itself, to make sure we have the colors correct, we're going to zoom in on this area, create another preview and select that galaxy. So that's going to be our white reference, so choose that as preview 3 or just whatever preview is set for that. The name is right there in this little box. Hit OK, and then go ahead and let that run. There we go. And once that's done, go ahead and auto stretch that, and you can do the green reduction for that. In Pixinsight, it's called SCNR, and click on that, and just click a little square again. And once that's done, you can go ahead and just auto stretch, make sure everything's correct. And you want to make sure the colors were calibrated properly. You do that just by going to a step that we are going to use either way, but you just want to test this first. You click on ArcSyn Stretch, which you go ahead and just type that in, ARC, it'll be right there, ArcSyn Stretch. You want to, before stretching, go ahead and open up this preview, and you can just bring up the stretch factor, make sure everything is the correct color, and if it is, you can go ahead and close back out of that. Because for now, we're just going to save this, save as. You want to make sure you have it saved as a FITS file, and we're going to take it into Siril to use for StarNet. Now, you can use StarNet on Pixinsight, but you have to install all the modules for it, and for me, for some reason, the modules are not working correctly. So I just take my file back into Siril, StarNet on there. So again, just want to check and make sure that everything is looking right, even when unlinked. It's good. So we're going to switch it back to linear and run StarNet again, just like we did while we were doing the Siril run through. So go ahead and hit execute and allow that to run. Once that's done running, you can check it, make sure everything worked correctly, and auto stretch, and looks good. So we can close out of this, hit exit, and it should already save them. As you can see, we have Starless C3 and Star Mask. Let me get rid of these other files just so that they're not in my way later on. And now we can take our Starless file and drag it and drop it into Pixinsight, and now we're going to edit this specific file. Now to do that, we're going to open up ArcSyn Stretch again, and we're going to set that as a preview. You don't want to overstretch it because you don't want the core to look too bloated. So go ahead and stretch it just enough so that the background doesn't look noisy, and hit the square button again. You want to lower down the stretch factor, and again, this is another one of those things that you really just need to play around with and see what works. Obviously, you don't want a super saturated background either, so you can go ahead and lower down the stretch factor. And again, just play with the stretch factor, play with the black point. I recommend you don't use black point on the first stretch, use it on the either second or third, and your image will look a lot cleaner. Once you're happy with how your stretch image looks, go ahead and press the square button, and you can close out of that. And here is your stretched image. Now, if you see that your background has coloration like this that you don't want, this is why Pixinsight is a better tool than Siril in general. You can go ahead and open up the range selection. And for me, I have to forget, I kind of have to go back and forth to show you guys where it is. Again, just type that in, range, and open up range selection. And this one is where it starts to get a little bit complicated, but it's still really easy to use. For this, we're going to open a preview again, and just drag this limit until you see the outline of the only things that you want to protect. For example, for me, I just want to protect the galaxies to make sure I don't make the coloration go out of those. So I'm just going to bump up the fuzziness, bump up the smoothness, and bump up the upper limit just so that it gets rid of all the background and leaves only my deep sky objects. I'm going to invert this so that it only selects the background now, and I'm going to press this little square, and that's going to create my mask. Now, how do you apply this mask to your deep sky object? Well, it's easy. You just drag the title and drop it here on the image, and now you can see all the red stuff is the stuff that's protected. The rest is what's going to be processed now. Next step we have to do is go to our curves, type that in, curves, transformation, open that up, and go ahead and create a preview again. And we're just going to lower down the saturation of the background here. So click on this little S and then drag this curve down. And as you can see, all of the color of the background went gone. It's not there anymore. The only things that have color are the deep sky object, which is great. This is what I wanted. Obviously, maybe you would want a colored background. Each person to their taste. Personally, I like having a blacker background. So I'm going to hit square on here just to save it like that. Now, if you only want to process the data, for example, the galaxy, go ahead and right click and just go ahead and invert that mask, just like this, invert mask, and now it is protecting the whole background and only selecting the data. Now, personally, there's nothing I want to do, but if you wanted to do something with it, you could just go ahead and do a curve transformation again and bump up the saturation, just like that, to give you more coloration in your image. Make it more vivid, more lively, and actually I like how this looks, so I'm gonna go ahead and press this square here. Now I'm just gonna go ahead and close out of that. As you see, everything's saved, and just to get rid of that mask, we're gonna go ahead and click mask after you right click, just so you know, and remove mask. Now, here's what our image is looking like so far. In my opinion, it looks really nice, and I honestly like it more than I liked the Siril image, just because all the coloration looks a lot prettier, and it's just a nicer looking image in my opinion. Now, we go ahead and bring the star mask file in here. Just like that, just go ahead and drag and drop. And we're gonna bump the stars up a little bit. Again, we're gonna open up the ArcSyn stretch, make a preview of that, and just bump up the stars a little bit so that they don't look too small. And we're gonna go ahead and hit the square here once you're happy with the size, and go ahead and close out of this. Now the next part, it might seem complicated because I'm gonna say math, but the next step we're gonna use is called pixel math. If you're not good at math, don't let that bother you. We're not doing real math. We're just gonna do pixel math, just digital math. So type in, again, pixel math, and it should show up pretty fast. It's the only one that has that name. There we go, pixel math, open that up. And you really don't have to do much. We're just gonna combine the stars with starless file. So for that, we hit expression editor. We're gonna click on the starless mask, double click that, space, add a plus there, and then hit star mask. Again, double click, hit OK. You want to make sure that it creates a new file. So for that, just go ahead and hit create new image and press the square here. And as you can see, we now have our image, but with the stars included. If you want to kind of darken the background a little bit more, just go ahead and go to Process Console, go to Histogram Transformation, open that up. Again, run preview, and kind of bring up your darkness here. And there we go. Hit the square, close this, and here is our final image. I really like the way that it looks. Again, a little bit more than the Siril image looked, and honestly, in my opinion, it looks better because the core is not super blown out and the galaxy just looks like it's glowing more. So I'm gonna save this. Again, save as, you want to set this as a PNG, and let's compare the two. So here is the image that we recorded with Siril. As you see, it's kind of blown out, but it's still a nice looking image. Again, these were the basic steps on how to use it. It's not super complicated. Hopefully this video was able to help you out a little bit. And now let's take a comparison with the one in Pixinsight. And obviously, as you get more advanced in Pixinsight, there's a lot more tools that you can use. Example, Easy Denoise. Once you get that installed, it will get rid of a lot of this background noise and somewhat blur the image, so you don't have your image looking as grainy as this. But overall, the colors just look nicer within Pixinsight. But again, it's all to one's own. Each art style is different, and for each program that you have, hopefully this video is able to help you out to learn how to use them and get a better post-processed image. But the question is now, as I mentioned, I do need to get more exposure time because my telescope is an f7 telescope. But how do you know how much exposure time you need based on your focal length? Let's find out in the next episode of A Beginner's Guide to Astrophotography.